My name is Jeffrey Frankel, and in this series of YouTube videos I will show you techniques and tips to reduce the time it takes to deal with questions in paper 1 of the IB chemistry exam at both standard level and higher level.
This is one of those questions where you have to memorize either the units or a method for calculating the units. Let me show you a method for calculating the units. Let's take first order. The rate equals K times concentration of, let's say, A. Now, rate is a change in concentration with time, so it's C over T. And for the moment I'm using C for concentration, and I'm also using T for time just to simplify matters, and that equals Kc. And as you can see, the C's disappear and K equals 1 over T. So if time is seconds, it's S to the minus 1. If time is minutes, it's minutes to the minus 1. And that's the unit for K, okay, for first order. Let's go to second order. And the rate equals K times concentration of A squared. It could be A times concentration of B, but it's not relevant. Let's simplify it and use A squared for calculating the units. It doesn't really matter. So the rate is still C over T, and that equals K times the concentration squared. One of those C's disappears, and we get K equals 1 over Tc. Now, I will now put in the C equals. There are two ways of writing the C, moles over dm3 or mole dm minus 3. Whichever is easier for you in these kind of calculations. We'll now substitute that C, and that equals 1 over T mole and times dm3 on the top, and that means, and we'll now substitute that by minute. So that's dm3 mole minus 1 minute minus 1. Lo and behold, that's the answer. So we know we've got that's here C. That's C, that's the answer. Let's do third order. Third rate equals K times A cubed, and therefore C over T equals Kc cubed. C's change, cancel out, and K equals 1 over Tc squared, and that equals 1 over T. C squared is mole squared times dm6, which equals, and again I'm substituting minutes for time, so I put dm6 mole minus 2 minutes minus 1. The interesting thing is with this, as soon as you see this 1 over T, 1 over Tc, 1 over Tc squared, somebody can give you any rate, the ninth order rate, and you'd immediately say, 1 over Tc 8, and you could quickly work out what the units are in this. There are two ways of doing this, or maybe more than two ways. There's either you remember 1 over T for first order, 1 over Tc for second order, 1 over Tc squared for third order, or you remember the final units, S minus 1, dm3 mole minus 1, minute minus 1, dm6 mole minus 2, minute minus 1, or you learn how to do the whole process. Just one thing about the order. I understand that the order is not important. Some people like to put moles first because it's quantity per volume per time. Others think that it's more important to have positive powers at the beginning and then the negative powers later on. But for your exams, so long as you get the correct powers for each of these, you will be okay. Having done the previous question, we now know that the order of this reaction is 1. and this is B. So there are two different ways they can ask this question. They can give you the unit and ask you what is the order of the reaction, or they can give you the order of the reaction and ask you what are the units for it. This is one that shouldn't take you more than about 10 seconds to realize. You know that when the temperatures increase, the rate must increase. In other words, K increases. And in fact, the only one where K increases is A. And you also do know that the energy of activation is unaffected. So the answer is A. As I say, this really shouldn't take more than 10 seconds. Well, we know that the effect of adding a catalyst to the reaction mixture at equilibrium and its effect on activation energy is to reduce the activation energy. However, it reduces the activation energy in both directions. So we go down here and we find this one. And this is clearly the answer. It decreases the activation energy of both forward and reverse reactions. And that is the answer. If you look at this one, and you think about it, you realize that the enthalpy changes both forward and reverse reactions are not changed. Because if you do that, like that, or you do the reverse, like that, this is the enthalpy change. This is the enthalpy change. That is not changed if energy of activation is reduced. So if that's the energy of activation, and that's reduced, this is not changed. And it's the same here. If that is the energy of activation, and this is reduced to that, this is not changed. And that's the enthalpy change. That's the enthalpy change. Therefore, D is not correct. Only C is correct. And once again, an increase in reaction rate is due to an increase in collision rate. Yes. Decrease in activation energy? No. In the absence of a catalyst, there is no decrease or change in activation energy. An increase in the number of molecules that react? Yes, that is true. As you increase the temperature, there are more molecules that react. So 2 is wrong, 1 and 3 are correct. 1 and 3 only. Perfect. The Arrhenius equation does not appear frequently in examinations. However, when it does, there are limits to the questions they can ask. And there are some things you just have to remember. The graph produces a straight line due entirely to D, the relationship between ln K and 1 over T. You simply have to remember that it's log K, natural log of K, versus the reciprocal of temperature, which is Kelvin. And it looks like this. If they give you a graph of it, an actual graph, it looks like this, and there is where ln K is, log of the rate constant, and this is 1 over the temperature. If they asked you to extend this line, let's say to that point, then when 1 over the temperature is 0, the ln K equals ln A. That's the log of the Arrhenius constant. The other important thing about the curve is that the gradient is minus EA over R. The gradient equals minus EA, the activation energy, over R. And R is the gas constant. But the graph and that line you simply have to remember.
If you found this YouTube video helpful, please say you like it and subscribe to my channel and look at my other YouTube videos. Thank you.